Hey guys, Mr. Kyle, Myers Mathematics, and let's just jump right into it. So today I want to talk about a few things. This is not one of those videos where you need to watch it in its entirety. I don't care about watch time and all that, just care about you getting what you need to do well today, specifically on the SAT math no calculator section. So first things first, before we get into me actually showing you how to solve it in real time here, they have real solutions. So all I did was I went over here and I just searched on Bing, because I use Edge, that way I can write on the pages. I just searched practice test 3 SAT, and it's the first thing that comes up. There's a couple other links though that come up that are also really good, and I'll show you them here. So this one is the answer explanations, and I have it already ready on section 3, the math test no calculator. Question 1, answer choice is C. Spoiler. So that's going to be where we start there, and then you can just kind of go through here. So I'm gonna kind of scroll a little bit here, and if you find a question that you want to pause it and kind of take a look at it, go ahead. I'll just kind of scroll through here. But you can do this yourself, and I'll put the link in the description below. So you can see all the answers here. So the idea here is not that I'm trying to just get all the questions right the first time and show that I can get all the questions right. The point here is to show you how to get the questions right. And then on some of the more difficult ones, maybe I'll do a separate example as well. All right, so almost done there. As always, you can scroll ahead to whichever part of the video you want to see, because this video is probably going to be a little bit longer. So there's all the questions there, and I'll go ahead and scroll back. Let's see if I can scroll back to, here we go. If it'll let me. Okay, let's just do this. Okay. So back to question 1, and we'll just leave it here in case we need to go back and look at the answer explanation. But there you go. There's all the explanations. Here's the scoring guide. So I went ahead and blotted out all the stuff from the calculator section, because I'm not sure if you would have done the calculator section yet. If you're watching this, maybe you did the no calculator, and then you're looking to see how to solve some of the ones that you missed on the no calculator. That's kind of the idea here. So if you haven't taken the calculator section yet, or you just don't want to see the answers for those, I blotted them out, but I'll also put the link for this one in the description below, so that way you can see for yourself what those answers are if you would like to. So let's go ahead and go back, and we'll just start on number 1. Again, the point of this is not for me to go through it like I would be actually taking this. The point of this is to go through it and explain each one. So I'm just going to go in order. I'm not going to skip any or do any other SAT tricks. I'm just going to go 1, 2, 3 all the way to 25. All right, so let's go ahead and get started. In walls. I'm marking the text here. Circle all the things that are important. And then what do all the things mean? Well, N is the number of walls. K is a constant of blah, blah, blah. L is length. H is height. Okay. So they want to know if the customer to a more expensive brand of paint, which of the factors in the expression would change? Okay. They want a more expensive brand of paint. So which of the factors would change? Well, H is the height of each wall in feet. L is the length. N is the number of walls. So none of that would have to do with the actual paint. K would be the only thing that has to do with the paint. So even if you don't know what they mean by a constant with units of dollars per square foot, if you don't know exactly what that is, that's fine. It's just not the other things. So that's the cool thing about multiple choice. You don't really have to know what the other things are. Number 3, actually, you know what? Let's just go in order. Number 2. If 3r equals 18, what's the value of 6r plus 3? So there's always a simple and easy way to do things. The simple way is always to just solve, and then plug in. Not necessarily in that order. Sometimes you can plug it in and then simplify. But I'm going to, with each of these problems, show you the easy way instead of the simple way. The simple way would be to solve for r and then plug it back in. I'm going to show you the easy way, which means that it's going to take less steps, but you kind of have to think about it a little bit and see the trick. On a lot of SAT questions, there's a trick. On this one, the trick is, if I just start here, I need to arrive here. So just multiply by 2. And I have 6r equals 36. And then just add 3 on both sides. So 6r plus 3 equals 39. So the answer is 39. All right. So there we go. Number 3. Now, what I'm going to do with this one is, it's a really simple question, but if you were confused at all on this, the way to remember what to do with this guy is the roots are always below the ground. So that's the way to remember this one. The roots are always below the ground. Right? So roots are down here. That's a cube root, so it had to be either C or D. And then it was the square power, so it had to be D. All right, number 4. Number 4, actually, the first time I looked at this, I was a little confused because I was like, wait, this is not a span of 50 years, because that is. And I was like, what's going on here? Because there's so many numbers, it can be a little confusing. If you were actually going to take the SAT and you saw something like this, I would probably just skip it because there's just a lot of numbers, even though it's not that hard of a problem. There's just a lot of things going on here. So there's a bunch of different dates. Notice they repeat the same 2, so there's really only 2 different dates. Now they say the number of states that join the Union between blah, 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 blah is, okay, so the number of states, whatever that is, we'll say n for right now, it's going to be equal to twice the number of states that join between 1850 and 1990. So let's say times x. If 30 states joined, okay, so n is 30, and x states joined between 1850 and 1990, which of the following equations is true? Well, you don't have to solve it. X would be 15. But you don't need to know that because there it is. Boom. All right, number 5. And as always, reminder, you can always scroll to the problems that you've missed. You don't have to watch it in its entirety. The way to solve number 5 is actually, there's actually a really cool way to do this. It's kind of a what I like to call big brain way to do this. The simple way would be to solve for x. Right? So if you're going to solve for x, cross multiply like that, solve for x, and then divide your answer by 5. So that is actually what I would recommend doing. If you want to know what the trick way is, it's a little bit extra tricky on this one. You would actually flip both sides of the equation. And then you have x over 5, and let's go ahead and split up that fraction, plus 20 over 15. And then I can actually write this in terms of x over 5. So x over 5, if I were to multiply x over 5 by 1/3, it would be x over 15. Because remember, I'm kind of wanting to know what x over 5 is. So I'm really trying to solve for x over 5. I wouldn't recommend doing it this way unless you want to be really tricky. It pretty much takes the same number of steps. So it's not a really, really good trick on this one. It's just kind of a good trick. You can simplify this fraction a little bit. Those numbers both go into 5, 4 times and 3 times. Then I could subtract 1/3 x over 5 on both sides, and I would have 2/3 of x over 5 on both sides. Then I can multiply by 3/2. Again, this is kind of a trick method, so it's a little bit confusing. I wouldn't recommend this. If you are currently pulling SAT scores between 2 and like 500-ish, I wouldn't recommend doing it like this. If you're already pulling SAT scores that are between 650 and 750 and you're just trying to eke out a few more points, then I would say, go ahead and do this. It just kind of depends on where you're at. 3's cancel. 4 over 2 is 2, so the answer is 2. All right, cool. Number 7. Function blah, 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 blah. Which of the following must be a factor of f of x? So we have all this data here. Which of the following must be a factor? Well, a factor just means something being multiplied. So we're saying which of the following must be a factor, a thing being multiplied by f of x. So it's either x minus 2 or x minus 3, x minus 4, or x minus 5. Kind of didn't really fit in there. So it's one of those, and I don't know which one it is, but it's one of them, right? So if that's a factor of f of x, then what that would mean is if x were equal to 2, then this would be 0. 0 times anything is 0, so f of x would be 0. If x minus 3 was a factor, and I plugged in 3, then f of x would be 0. So a factor is going to result in f of x equaling 0. F of x equals 0 right here. So that means that 4 must be the factor, which means x minus 4 would be the answer. All right, moving on. Oh, I kind of skipped on that one. I skipped 6 and went to 7. I'm so used to just going from left to right like you read. On this one's actually really cool. The trick that you can do on this one, very, very, very cool. So the normal way to solve an equation, a system of equations, is to eliminate either x or y because they're lined up. If they're lined up, the best way to solve it is by doing elimination. So we could either multiply the first equation by 3 and then the second equation by -2, or kind of do the reverse to eliminate the y's. But remember I said I'm not going to show you the simple way. I'm going to show you the easy way to solve these. The easy way would be to just add them up, because I get 5x minus 5y equals -20, and then divide by 5. So then I get -20 over 5, which is equal to -4, which is the answer. Okay, so if you were like, whoa, I didn't even think of that. Well, to be fair, I didn't think of that at first either. I actually solved it the simple way the first time I solved this problem. And then I only figured out the trick way later on. So you won't always see the trick, but a lot of times there is a trick. If it takes you more than 10 seconds to try to think about what the trick to the problem is, if you kind of have a sinking suspicion there is a trick way to solve it that saves you time. If you have a sinking suspicion that there is one, there probably is one. But if you're going to take more than like 10, 20 seconds max to try to figure it out, you're really not saving time. You're kind of wasting time at that point. So just be careful with that. If you don't see the trick and you just can't figure out what it is, either there isn't one or you just don't see it. So don't worry about it. Just solve it the simple way. All right, number 8, the line blah, 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 blah. What is the slope of the line in terms of C and D? Okay, well, we know the equation for the slope is right here. And so if we want to know slope, shouldn't we use the slope equation? M equals y2 minus y1 over x2 minus x1. So we should do that. So we just need 2 points. Well, we know this is a point, so we can plug that in. So let's see C and D, let's say that's x2, y2. But I need an x1, y1. And they don't really tell us what 1 is, but they kind of do, because if x is 0, y is 4, no matter what k is. That's our y-intercept. So we do kind of have 2 points here. We know the y-intercept because of that number right there. And then we know C and D, which is, what all these answers have in here. So k is equal to y2, d, minus y1, 4, over x2, c, minus x1, 0. And of course, c minus 0 is c, so it's d minus 4 over c. Final answer, there's number 8. All right, I'm going to try to go in order now. Try to do number 9 and then 10 before I do 11. In the system, k is a constant x variables. The system have no solution. Okay, so for what value will it have no solution? Meaning the slopes are the same. Slopes are equal. So I just need to find out what the slope is of each equation and then set them equal. And then there we go. If there's no solution, then the slopes have to be the same, right? The lines would never cross. That's how there's no solution. They never cross, so there's no solution. All right, Let's start with the second one. 4x minus 5y equals 7. So let's subtract 4x plus 7. Y equals, and I'll just stop with the slope. I don't need to keep going. I would divide negative 5 on both sides, so the slope is 4/5. All right, done. Kx minus 3y equals 4. All right, so then negative kx plus 4. And then I would divide by negative 3, so negative k over negative 3, which is k over 3. So k over 3 has to equal 4/5. So then all you need to do to solve for k is just multiply by 3. Boom, boom. 3 times 4 is 12. 12 over 5 is la respuesta. That's A. Right? And I can plug it back in to check. There is a letter D with a negative 12/5. So always be careful. If there's an answer with a negative sign on there, there's a possibility you got your signs wrong. So always check. I'm not going to do that here, but if you were to plug it back in, it would work. All right, number 10. XY plane parabola with equation, blah, 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 intersects line between 2 points. What is the length of AB? Okay, so if it intersects, that's a solution. That's a solution if it intersects. Now, this is not a system of 2 linear equations, but it's still a system of equations. So the best way to solve it is, well, it would be graphing if you could graph on a graphing calculator, but this is non-calculator. So the best way to solve it would be substitution. They're both equal to y, so we can set them equal to each other. 25 equals x minus 11 squared. Take the square root of both sides. Anytime you take the square root of both sides, you have to do a plus and a minus. So we have that. So 5 equals x minus 11, or negative 5 equals x minus 11. Add 11 to negative 5, you get 6. Add 11 to 5, you get 16. Excuse me. So that means that they cross at 16 and 6. Those points do. So the graph would look something like this. Right? Y equals 25 is a horizontal line, so it crosses here and here. The y value of the point is going to be the same. It's going to be 25. So that part doesn't really matter. We want the distance between them. Well, if it's a horizontal distance, all we have to do is count the points, count the distance, which is x. So between 6 and 16, I have 10 spaces to count. All right. So for this one, we're given 2 equations. Well, 2 sets of equations. 1 from here and 3 equations just from this alone. So we know that y is equal to u, because they're vertical. X is equal to z, because they're vertical. Or sorry, x is equal to t. I got that wrong. X is equal to t. And z is equal to w. There we go. Okay. Well, if y is equal to u, that means that they're the same measure. So I can get rid of them from both sides here. X is equal to w, which means all of this stuff is equal to each other. So x equals t equals z equals w. Well, then that means x equals z is true. Y equals w? Possibly. I mean, they all look like 60 degrees, but we don't know for sure. So we don't know. It has to be what must be true. And then z equals t. That's true. So it's only 1 and 3 on this one. All right, number 12. In the quadratic equation above, a is a non-zero constant. The graph of the equation in the xy plane is a parabola with vertex c, comma d. Which of the following is equal to d? So with this kind of thing, you can actually plug in numbers if that helps you, because there's a lot of letters. You don't really need to, but you can. You can either multiply all this stuff out here and then use the vertex formula. Or there's actually another thing you can do, is you can find out what the x-intercepts would be, 2 and negative 4. And the vertex is always, of a parabola at least, right in between the 2 x-intercepts. So what's right in between them? Well, we'd have to find the average. Add them up, 2 plus -4 is -2, and then divide by 2, you get -1. So the vertex is going to be at -1 comma something. We need to know what D is, which the following is equal to D. We know what C is now. C is -1. All we have to do is plug it back in. So A times X, which is -1, minus 2, and then -1 plus 4. So A equals -3, and then -1 plus 4 is +3. 3 times -3 is -9. So the answer is A. And there we go. Number 13. So in the equation blah, 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 X is not equal to 2 over A. They only have to say that because the denominator can't be equal to 0. So this is not really important information. A is a constant, also not really that important. What's the value of A? Okay, so if we're going to find out what the value of A is, basically the trick to this one is that you have to notice that you divided. You have to notice that you divided the two things, because this is a remainder. So this is kind of a tricky problem because you have to notice that long division happened here, which is kind of what you do in geometry algebra 2, long division of polynomials. But that's kind of what's happening here. So you could also use synthetic division a little bit, but I would recommend long division. When you do long division, basically what you're saying is, okay, 24x squared plus 25x minus 47. Top number always goes in the box, bottom number outside. And I'm supposed to multiply something by ax minus 2 to make the 24x squared cancel. Well, we already know what the answer is. We know it's this. Minus 53 over ax minus 2. So we know the answer is -8x times ax has to be 24x squared. Well, the x squared is already taken care of. So -8 times something equals positive 24. Well, that means it'd have to be -3 to get positive 24. Right? And you could check it if you wanted to. -3 times -2 is positive 6. So subtract, that goes away. 25 minus 6, well, that would be 19. And then -3 times -3, that would give us, hold on, -3 times -3x would be positive 9x. What am I doing here? I must have did something wrong. Hold on. Oh, -8x times -2. That's what I did wrong. -8x times -2 would be positive 16x. There we go. And then I get positive 9. I made a boo-boo. My bad. So 9x, and then -3 times -3 is positive 9, so then it'll be positive 9x. There we go. Okay. So you don't really need to do that if you recognize what's going on. All you need to do is if you recognize, hey, long division is happening here, really all you need to do is just say, hey, what do I divide by here to get this equal to this? And the answer would be -3. So, boom. All right, so number 14, what are the solutions to this? If you look at the answer choices, they're all in the form of quadratic equation. So obviously quadratic equation has to happen. But before you do, you want to make your life as easy as possible. All right, so divide everything by 3 first, and you get that, that, and that. So then A is 1, B is 4, C is 2. Negative b plus or minus the square root of b squared is 16. Minus 4 times a times c would be 8, all over 2a. 16 minus 8 is 8. The square root of 8 can be simplified. So yes, you have to know how to simplify your radicals. If you do not, I would highly recommend looking up a worksheet on that. Type in something like simplifying radicals CUDA, K-U-T-A. And you can pull up a CUDA worksheet on it and get some practice with that. But anyways, there'd be 2 root 2 over 2. Everything divides by 2, so if I divide everything by 2, I would get -2 plus or minus the square root of 2, which is a. All right. Number 15. This one's a little tricky, but I'm going to show you a trick to the trickiness here. And actually, before I do, let me get rid of some of this work, so it's not crowding my number 15 here. Okay. So this is actually the way to convert degrees centigrade Celsius, sorry, with degrees Fahrenheit. But you don't really need to know that that's a legit formula. You just need to kind of take their word on it because they're the ones that are telling you it is. So let's go ahead and look at what they're saying here. They basically say which of these things is true. We need to know which thing is true. Well, in order to know which thing is true, we just have to kind of figure out if what they're saying is legit or not. So they're saying in number 1, a temperature increase of 1 degree Fahrenheit is equivalent to a temperature increase of 5/9 degrees Celsius. So let's start off with an easy one. Everybody knows, or I guess I should say it's common knowledge, that if you have 32 degrees Fahrenheit, that's 0 degrees Celsius, right? That's the freezing temperature of water. And you can do that by plugging it in, right? 32 minus 32 is 0. 0 times anything is 0, so that works. Now, if the Fahrenheit was 33 degrees, let's say it increases in 1 degree Fahrenheit, well, then that would be 33 minus 32, which would be the 1. 1 times any number is that number, so the Celsiuses would be 5/9. So yeah, it looks like it does increase by 5/9. Number 2, a temperature increase of 1 degree Celsius is equivalent to a temperature increase of 1.8 degrees Fahrenheit. That's like a really oddly specific number. So it makes you wonder, like, hey, are they trying to be tricky? Or is that just like that random number because it is true? Well, let's find out. We know Celsius 0, Fahrenheit 32. So let's just kind of go off of that. Let's increase the Celsius by 1. So 1 equals 5/9 F minus 32. Okay, well, if I multiply by 9/5, I have 9/5 equals F minus 32. So basically, 9/5 plus 32 equals Fahrenheit. So it increased by 9/5. Well, is that 1.8? Let's find out. Top number goes in the box, bottom number goes outside. That goes in one time evenly. 4, point, drop a 0 down. 5 goes into 48 times, so yes, it is true. It looks like Celsius was 32 plus that 9/5. It was 32 plus the 9/5. So yeah, if you increase the degree Celsius by 1, the Fahrenheit goes up by 1.8. True. Now, before we go into number 3, if you look at the answer choices, A, B, and C say 1, 2, and 3 only. D says 1 and 2 only. We know for sure that 1 and 2 work, and so that means that logically 3 does not work even without checking it, because the only 2 that can work are 1 and 2. There is no answer choice for 1, 2, and 3. Right? So whenever you're solving things like this, remember to be tricky. Remember that multiple choice is a thing. Only do math as far as you need to. Because let's say in number 3, you somehow made a mistake and you figured out, hey, number 3 seems like that's right. Well, then you look at the answer choices and you're like, oh, wait, 1, 2, and 3 can't be right. Oh, now what? Right? So just solve what you need to solve. Check to see if you need to go any further periodically. And if you do, keep going. If you don't, then you're good to go. Right? So anyways, number 16. All right, so now we're on the fill-in. Now remember, the fill-in, basic instructions here are, hey, you can put in fractions, you can put in decimals. You can also put in repeating decimals, which I think is really cool. You also don't have to round them properly. You just have to write them out as far as they go. So you can round it or you can just not round it. But yeah, so basically it can be on the left side, the right side, whatever. Trying to scroll and I was not scrolling. So you can put your answers on the left, you can put them on the right, you can do a decimal, you can do a fraction, but it has to fit. So if you get a really big number that just doesn't fit, then that's definitely a red flag. You did something wrong. All right, so anyways, number 16, x is greater than 0. What is one possible solution? Well, one possible solution here would actually be 0, because if x is 0, then the whole thing is 0. But x cannot be 0, so we have to kind of figure something out here. Let's go ahead and divide everything by x, because x equaling 0 is one of the solutions. and I don't care about that solution. I only care about the rest of them. So then if I multiply this out, actually, I won't do it. Okay, so x to the fourth minus 5x squared. And then if I add 4 to both sides, then I would get this. And then I can factor this. This factors 4 times 1 is 4. Negative 4 plus negative 1 is negative 5. So we can do factors. And then you can actually factor it even further. This would be x plus 2, x minus 2, x plus 1, x minus 1. So there's a bunch of possible answers. Only 2 that meet this criteria, though. 1 or 2. So there's actually 2 answers. They say, what is one possible solution? There's actually 2 possible answers to this, which is okay if you get more than one answer, especially if it says, what is one possible solution? That kind of means they're hinting at there's more than one anyways. So that's okay. Also, if you were like, oh, hey, negative 1 works. It does, but it says x is greater than 0, so it doesn't. Also, you can't put negative numbers into a grid, so that should definitely be a red flag. All right, number 17. There's just a ton of fractions, but before you try to just multiply everything by the least common denominator, these already have a least common denominator, so just go ahead and put those together first. That's 3/9 x. 1/4 plus 5/12. I'm not even going to try to add those fractions, because once I have this, I can simplify it. And then my LCM is really easy. My LCM now is actually just 12. So I'm just going to multiply everything by 12. 12 over 3 is 4, so that's 4x. 12 over 4 is 3, so that's 3. And then 12 over 12 cancels, and I have 5. So then 4x equals 8, x equals 2, and there we go. There's my answer. All right, the answer was 2 for that one as well. Number 18, the first time I did this one, I actually solved for the base angles of triangle y. And then I was like, oh, wait, I didn't need to do that. That was dumb. So if you find extra information they don't need to, don't do what I did and feel dumb about it. It's fine. You're just finding extra information. Just try not to find any extra information if you can help it, and just solve what you need to solve. So y is 75. That's there. And then they give us this equation. So we have this, which I actually just applied, and then we have this as well. And we want to know what's the value of x. Right, so we're solving for x. Easy enough. Well, we can actually just solve this like a system. 180 minus z equals 2y. Well, y is 75, so 2y is 150, which means 180 minus, well, 30. There we go. Z, that was a terrible z. Z is 30. All right, boom, there we go. Okay, so z is 30. Let's go ahead and put that in here, my picture. 30. And then x. So they didn't give us any other information. We're kind of stuck now. But one of the only helpful things that's actually on your formula sheet is that all the interior angles of a triangle have to add up to 180. So whatever this and this is, and I'll put extra tick marks here. Whatever this and this is, let's call it n maybe. Whatever those are, they have to add up to 360. And I know they're the same n because it's an isosceles triangle, so you do have to know that the base angles of an isosceles triangle are the same. So be careful there. So this would be 30 plus 2n equals 180. So 2n equals 150. You should be having some deja vu at this point because we're solving this and we're actually ending up with 75. Now, this doesn't always happen, so don't think this is like a pattern, a thing. But the formula actually ended up giving us 75 again. So n is 75. Remember, that's not the answer, though. We need x. Well, n plus x has to be 180, so x has to be 105. 105 plus 75 is 180, and these have to add up to 180 because they are on a line. Right? If two angles are on a line, they have to add up to 180. It's this linear pair thing. Whew, geometry. It's bringing you back, I'm sure. So the answer is 105 there. All right. Number 19 and 20, we're almost done. I don't understand each hamburger has 50 more calories than fries. Okay, 50 more than the order of fries. This is all kind of important, actually, because this sounds like a formula. If 2 hamburgers and 3 orders of fries have a total of 1,700 calories, how many calories does a hamburger have? So we want to know hamburgers. Hamburgers. Okay, well, it says here hamburgers have or has is past tense. If you have something, it's basically the same thing as equals, right? If you have, or if you has, or if you're going to have, right? Whatever past, present, future tense of that word looks like, it basically translates to equals. Just like is, was, and is going to. It translates to an equal sign. So H equals 50 more plus calories than each order of fries. So there's one of our equations. And then the other equation is kind of given to us as well. If 2 hamburgers and 3 orders of fries have, see that? Have a total of 1,700 calories, how many calories does a hamburger have? Okay, so you can do this one of 2 ways. You can either do substitution just straight up because it's already set up for substitution. I would not recommend doing elimination unless you just absolutely get every substitution problem wrong ever in your life and you get every elimination problem right in your life ever, always. So you're like 0.01% of the population. Anyways, I would recommend doing substitution on this one because H is already solved for. However, if you subtract 50 on both sides, you can actually do a little bit less steps, kind of basically the same number of steps because you'd have to plug it in anyways, but you could subtract 50 on both sides and plug in F and then solve directly for H, which is what they want. So I'm actually not going to do that. I'm not going to take my own advice on that one because it takes the same exact number of steps. So it's not really a better way. It's just kind of like another way to do it. So I'm not really going to need this too much. So I'm kind of just going to go over here. 2H is 50 plus F plus 3F equals 1,700. All right, so that's 100 plus 2F plus 3F equals 1,700. I'm going to go ahead and do 2 steps here to save time. Subtract 100, I get 1,600. Divide by 5. Now, the trick to dividing by 5s really quickly in your head is really cool, actually. You can do one of 2 steps, and you don't have to do them in order. So what you do is you take off a 0, take a 0 off, take a 0 off, and you double the number. Double the number. Okay? And the reason why that works is because 5 is the same thing as 10 divided by 2. So basically it's, yeah, anyways. So if I'm dividing by 5, I'm basically dividing by 10 and then doubling it. Or you could do it the other way around. So if I take off a 0 first, I have 160. And then if I double that, I have 320. Right? So little trick, if you ever get stuck thinking what 1,600 divided by 5 is, you don't need to do that out loud, not out loud, on paper, on your scratch sheet. You can actually do those pretty easily in your head just by doing that little trick. If you don't have a 0 to take off, I would recommend doubling the number first and then taking a 0, quote, taking a 0 off, meaning move the decimal place over. Because if you don't have a 0 to take off, your number is likely going to be a decimal answer. But anyways, F is 320, but we're not done because remember, we want to know the number of hamburgers, hamburguesas. So we want to take F, 320, and add 50 to it. That's not too hard. 50 plus 20 is 70, so 370 is the answer. All right, last one. In triangle ABC, the measure of angle B is 90 degrees. Okay, so let's go ahead and draw this. Get an idea of what this looks like here. So angle B is 90 degrees. BC is 16. AC is 20. Okay. Triangle DEF is similar. blah, 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 blah. It's a little bit smaller. It's 1/3 the size. That doesn't matter that much. Let me draw a better triangle, though. It's 1/3 the size. DEF, so DEF. You'll find out that the 1/3 the size thing actually doesn't matter. It's completely superfluous, to use a Englishy word. There you go. I'm helping you with your English section too. This is totally useless information. I'm going to show you why. If they are similar, as they say here, right? So there's some important information there. If they're similar, that means all the angles are the same. So that angle and that angle. All the angles have to be equal in similar triangles. So if I want to know what the sine of f is, the sine of f is actually the same thing as the sine of c, since they're the same angle. It doesn't matter that the sides are bigger because you're dividing. So it would be easier to find out what the sine of c is since we know at least 2 of the 3 values. Now, we can use Pythagorean Theorem to figure out what the third value is. I'm going to set up the equation, but I'm actually not going to solve it. I'm going to show you a faster way. It might be a little confusing at first, but if you practice recognizing this, it will save you time. So a, let's just say, is 16 squared plus b squared equals 20 squared. So then blah, 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 you'd solve, and I think you get 12. And here's why I think you get 12. So remember how in geometry you learned about Pythagorean triples? Well, the classic Pythagorean triple is 3, 4, 5. Now, that also means that any multiple of that is also a Pythagorean triple. So that means 6, 8, 10 is a Pythagorean triple, right? Multiply it all by 2. If I multiply it by 3, 9, 12, 15. Multiply it by 4, 12, 16, 20. Hey, look at that. 16 and 20. We have those sides already, which means the missing side is 12. Okay? So a little bit tricky, but if you recognize 3, 4, 5, 6, 8, 10, 9, 12, 15, 12, 16, 20, if you start getting familiar with some Pythagorean triples, you can save yourself a ton of time in computing the missing side. Okay? So we know the missing side now is 12, and then if you use your knowledge of SOHCAHTOA, some old horse caught another horse taking oats away, then the sine of c is opposite sine of c, which is sine of f, so it's the same thing, opposite over hypotenuse. Now, if I remember right, you actually don't have to simplify your fractions. I would check on that because I don't know if I'm 100% sure about that one. But I'm pretty sure, I'm like 80% sure that you don't have to simplify your fractions for your answer that you put in the grid. Again, check before you try this out. But let's go ahead and simplify this fraction just to be safe here. So divide by 4, divide by 4. So that's 3/5. And I would just type that in as is. I would just say 3/5. So 3/5. Okay. And you can do that in there. It would also be 0.8, but remember, do as little math as possible. That's always the golden rule when you're doing this kind of stuff. So anyways, that was all of the solutions to the non-calculator section of the math SAT practice test number 3. If you found this video helpful, like, subscribe, all that good stuff. But also I have a free guide called the 5 Math Mistakes That Everyone Makes and How to Avoid Them. It's on my website. It's awesome. It's just a simple little Google Doc that I just kind of threw together and then turned it into a PDF. And just 5 things that I've noticed that everyone kind of gets wrong. So there's a bunch of different ways you can mess up on a math problem, but there's really only 5 things that it actually comes down to. Some of them are a little bit more broad than others, but I'll tell you what, step 1, or the first and number 1 mistake that people make on math problems is missing out on a negative sign. So signs. So it's a really quick guide. It just has like, hey, problem number 1, this, and then it gives you a quick solution, and then it gives you like a paragraph or 2 of what that looks like and just an extended solution to that problem. All right, so the 5 math mistakes everyone makes and how to avoid them. Check it out. It's on my website. It's for free for you to enjoy. So speaking of, I hope you enjoyed this, and I will see you in another episode soon.